Okie doke. All right, Algebra 1. Yeah. Lesson 9. Can you believe it? 9 of them. So, we got this week, we're doing some graphing review. We're going to talk about graphing lines and graphing parabolas or quadratics. Next week, we're doing some solving review. So, solving linear equations, solving quadratic equations. And then the following week will just be kind of a recap of what we've done and nothing too challenging for the final week. And that's it. We have 3 more weeks left. So it's kind of crazy. I hope y'all are doing well. Let's just jump right in. Let's talk about graphing lines. So I'm going to put 3 equations up here. These are the first 3 that are on your assignment. And then you're going to have to do 5 problems. So you'll have 5 lines to graph on your assignment that aren't these 3. So here we have y equals 3 over 4x plus 5. That's one of them. Here we have y equals negative 2x minus 1. And we got one more here, which is 2x plus 5y. 2x plus 5y equals negative 10. Okay, so 3 equations for 3 lines. These 2 are in slope-intercept form. This one is in standard form. We'll talk about that one. So let's just go ahead and start here. If it's in slope-intercept form, what we do is just identify, hey, what's the slope, what's the y-intercept? So the slope here is always the coefficient on the x when it's in slope-intercept form. That means a number in front of the x. So here the slope is 3 over 4, which means rise over run, which means you go up 3, right 4, from the other point on the line. So you find a point on the line, up 3, right 4, up 3, right 4. Not from 0, 0, from the first point that you find. And that first point you find on the line is your y-intercept. And the y-intercept is always going to be 0, comma, that number that, remember it's y equals mx plus b? That b is the y value of the y-intercept. So here, I've got my slope, I've got my y-intercept. I can graph it. So I'm going to go ahead and draw in a grid here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, so on. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. Now I can go back this way. 1, 2, 3, 4, negative 5. Okay, this is going to look a little bit off because I did it all with dashes, but bear with me. Y-intercept is 0, 5, so we start at 5 on the y-axis, right? So remember it's x and y. Now what I do is I use my slope from the y-intercept. Remember this? And we go up 3, right 4. So I go 1, 2, 3, up, 4 to the right. And that's my next point, which is 4, comma, 8. And then do it again. Do it again. 1, 2, 3, and then over 1, 2, 3, 4. And now I can draw my line through it. I could also go backwards. So I go down 1, 2, 3, left 1, 2, 3, 4, right? And that's going to lie on that line as well. So it's up 3, right 4 to get to the next point. Okay, let's do the next one. So here you'll notice it's y equals negative 2x minus 1. So we look at it, it's like, hey, awesome, it's in slope-intercept form. What's the slope? The slope here is negative 2. That's is an integer, so it's not a fraction, but we can write it as a fraction as negative 2 over 1, right? Which means we go down 2, right 1. That's what our slope tells us. That negative means it's going down instead of going up. And then the y-intercept here is at 0, comma, negative 1. Now, if this was just a negative x instead of a negative 2x, it would be negative 1, so it would be down 1 over 1. If it's just an x, it's up 1 over 1. Just to let you know. Alright, so now let's go ahead and graph this. So I'm going to draw my grid. I'm going to start at negative 1. There's negative 1. 2, 3, 4, 5, negative 5. And then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So I got my grid. Now I'm going to put my line on it. start at the y-intercept, 0, -1. There it is. And then I'm going to go down 2, right 1, down 2, right 1, because it's a -2 for my slope. So down 1, 2, right 1, down 1, 2, right 1. Or I could go backwards, I could go up and left. So up 1, 2, left 1. And you'll see, wonderful, it's a line. Fantastic. Okay. So if it's in slope-intercept form, just look at it and go, aha, start at the y-intercept. Use the slope to build the other points on the line. Fantastic. Now here, this is in standard form. So there's a couple things we can do with standard form. One thing we can do is we can use the fact that it's really easy to solve for the y-intercept. So sorry, the x and the y-intercept. And how many points do we need for a line? 2. So what I can do is I can say if x is 0 for my y-intercept, then I get 5y equals -10. And I can divide by 5, and I get y equals -2. So I get the point 0, -2. That's when x equals 0. And then if I have y equals 0, I get 2x equals -10. Solve that, and that gives me x equals -5. So I get -5 comma 0. So here, I've got (1, 2, -2), and 1, 2, 3, 4, 5, -5. I've got those 2 points on my line. I can connect them to draw my line. Now, I remember some people kind of struggled with like what we call the cover-up method. Remember to find those intercepts when it's in standard form? So there's another thing that you can do. The other thing you can do is you can take this 2x plus 5y equals -10, that's in standard form, and you can rewrite it in slope-intercept form. Like if you're comfortable with this, then yeah, why not? So we go 2x plus 5y equals -10. We want to get y equals, because that's slope-intercept. We want y equals what? mx plus b. We want mx plus b, right? So just go, oh, let's just take away that 2x, -2x, -2x. Now, because that's got an x in it, I can't combine those. So here I get 5y equals -2x minus 10. Just write it out. It's like, I don't want a 5y, I want a y. Why? Why? Just because. So I divide by the 5, and I'm just going to divide each piece by the 5. It's kind of like distributing that division through the subtraction there. And I get -2/5 x minus 2. Oh, check it out. The y-intercept number is -2, and the slope is down 2, right 5. Or I'd go up 2, left 5. Boom, it's the same line. Okay, hopefully that jogged your memory enough to remember how to, well, graph some lines. So you got 5 of those, do those, and then I'm going to erase and then talk about graphing some quadratics. Yeah. All right, this is all first semester, like chapter 3, chapter 4 stuff. We did some of this stuff in 8th grade as well. So the lines hopefully aren't too bad. The reason that we're going back to this is that's one of those big things that I want you to remember and like take away from Algebra 1. When you leave Algebra 1, I want you to know how to graph a line. Like confidently, I can graph a line. So that way when you have to do that in other classes, you don't have to like relearn it every time. All right, so now let's talk about parabolas, quadratics. I don't know if you can hear my dog upstairs. She's barking. All right, so remember for a quadratic, for a parabola, it's when we have an x squared part. And then remember, if x changes from the vertex by 1, 2, or 3, either right or left, the y change is going to be the square of that. And that's where that 1, 4, 9 comes in. So if we can find our vertex for a parabola, for a quadratic, finding the vertex is key, then we just go right or left 1, up 1, right or left 2, up 4, right or left 3, up 9, unless there's a number in front of the x squared, If it's ax squared, some number times that, then we just multiply each of these 149 by whatever that number is. And that'll tell us the vertical displacement, distance with direction, from the vertex. And we're going to get to that. So the goal here is find the vertex. From the vertex, we can then find a few points on the right, a few points on the left, and sketch the graph. Oh, it's Emma! Nope, she doesn't want to come over here. The dog. Okay, so here we have y equals x squared plus 5x plus 6. So remember, if I want to find the vertex, this is in standard form for a quadratic. So what I do is I say x equals negative b over 2a. It's that first part of that quadratic formula that's right in the middle of the x-intercepts. Emma. Sorry. So I take negative 5, the opposite of that, divided by 2 times 1, which is negative 5 over 2. Uh-oh, a fraction. That's okay. It's just negative 2.5. You got that? No biggie. Right? And here the a value is 1, so I can just do the 149. But that's my x number. Now I need to find out what my y number is equal to. So I'm going to go negative 2.5 squared plus 5 times 2.5 plus 6. Oop, negative 2.5. Sorry. All right. So let me explain what I just did here. Took the equation, a is 1, b is 5, c is 6. I used the formula that we remember from chapter 8, which is basically part of the quadratic formula. It's the part that doesn't have a plus or minus on it. Negative b divided by 2a. Put in 5 and 1 for b and a. Found the x number of the vertex. Then I took that number and I replaced x in the equation so that I can find the y number. Hello, Emma. Come say hi. Come say hi. This is Emma. Hello. Hello. Okay. There you go. All right, so negative 2.5 squared is going to be, I believe, positive 6.25. I'm just going to check that. Yep, it's 6.25. And then here it's going to be minus, because I have 5 times a negative. So it's going to be minus 12.5. I'm just going to double check that as well, just to be sure. Just to be sure, yep. And then plus 6. Okay, so here, that gives me 12.25 minus 12.5, which gives me 0.25. So here's 0, negative 0.25. So that's the y number of my vertex. So here, the vertex is at negative 2.5, comma, negative 0.25. So when I graph this, what's going to happen, my x number is negative 2.5, so I'm going to go here. So 1, negative 2, negative 3, negative 4, negative 5, sorry, negative 1, negative 2, negative 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up. Okay, so to put this on the graph, what I do is negative 2.5, negative 0.25, that's my vertex right there. And then from there, I'm just going to go right or left 1, and up 1. Right or left 1, up 1. So I'm going to go, still be on the halves here, and then up 1, so just a little bit below. So that's like 0.75. I'm going to go right or left 2. And I'm going to go up 4. So I'm going to get 3.75. 1, 2, 3.75. There. And there. I'm going to go right or left 3. 1, 2, 3. So I'm at 0.5 for my x. And I'm going to go up 9. So I'm going to be just below the 9 there. And 3, just below the 9 there. And sketch in the curve. Cool. So for example, this is the point 0.5, comma 8.75. Right there. It was this, add 3 to the x, add 9 to the y. Now, for the actual assignment, I'll try to give you a vertex number that's whole numbers here instead of fractions. Sorry. Okay, let's move on to a couple different examples. So I'm going to erase this. I'm going to leave that up there, that 143, or 149 is good. We'll keep that. 149, we'll keep that. Erase this. I'll be a little bit quicker through the next examples, and we'll go from there. All right, so let's say we have y equals -3 parenthesis x minus 2 squared plus 3. Okay, so here this is in vertex form. If you remember from chapter 8, right? We had a whole section on vertex form. What this tells us is the vertex, it just gives us the vertex is the opposite of this number and that number. So it's 2, 3 for our vertex. Wonderful. So, and my a value is -3. So here when I've got my my x change from the vertex, my y is going to go 149 times -3. So it's, and because it's negative, it's going to go down. So what I'm going to do is I'm going to graph it like this. So 1, 2, 1, 2, 3, 4, 5, 6. And there's my vertex. Now I'm going to go right or left 1 from, oh my goodness, I goofed. What did I goof? X, Y, right? Whoops. So 3 is the y number, 2 is the x number, 2, 3 goes right there. Yeah, okay, so 2, 3, that's my vertex. If I go right or left 1, I'm going to go 1 times -3, which is down 3. So that's here and here. If I go right or left 2, I'm going to go down 4 times 3, which is 12. So I go 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is going to be down here at -9. So that's 2 over. And then if I go 3 right or left, it's going to go down 9 times 3, down 27. I don't really want to graph that far. So that's -10. So I'm going to go all the way down to -24. Yeah, I'm not going to make it. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4. Made it! Cool. Right, and then we get this graph. Connect those dots. So, if it's in vertex form, identify the vertex. X number is the opposite of this number. Y number is that number. And then do your 1, 4, 3 from the vertex, right? Direction from the vertex. And then go times A for the 149. So 1 times -3 is -3. So I go right or left 1, down 3. 2 to right or left, 4 times -3 is -12. So I'm going to go 2 right or left, down 12. So 3 to -9 is 12 down. 3 right or left from the vertex, I go down 3 times 9, or -3 times 9, which is 27, all the way down here. Okay. Not down to -27, I go 27 away from that vertex. And this is always from the vertex. Okay, one more problem, that's it. Then that's the end of the video. So here we've got y equals 2x squared plus 16x, 2x squared plus 16x, plus 24. So just like the last problem, just like problem 1 for the quadratics, but there's a number in front of the x squared. We got an a value that's not 1. So what we're going to do here is going to find the vertex by finding the x number at -b over 2a, right? Find the axis of symmetry. So -16 over 2 times 2. -16 divided by 4 is -4. So here, x equals -4 is our vertex, x. So I need to find the y number for the vertex. So I just go y equals 2 times -4 squared plus 16 times -4 plus 24. Multiply that out, right? 16 and 2 is negative, so that's 32. Remember, whenever you square a negative, it becomes positive. So I get a positive 32 there, plus -64, so that's going to act as subtraction, and then plus 24. So here, 24 and 32 are going to give me 56. And then basically I got to find out how far away 56 is from negative 64, and it's going to be 8 away. So here the y number is negative 8. If I combine all those, I'll get a negative 8. So here the vertex is at negative 4 comma negative 8. And then my a value, right, a equals 2. So when I start from my vertex, right, if I go right or left 1, right or left 2, right or left 3, my y is going to change by double those. So it's going to be 2, 8, 18. Okay, so let's go ahead and just graph it out now. So negative 4, negative 8. 1, 2, 3, 4, negative 4, 5, 6, 7, 8, negative 8. 1, 2, 3, 4, 5, 6, 7, 8, negative 8. So negative 4, negative 8 is right there. So that's my vertex at negative 4, negative 8. And then I'm just going to go right or left 1, up 2. So go right 1, up 2, left 1, up 2. Right or left 2 from the vertex, up 8. So over 2 from the vertex, up 8. It's going to put me at 0. Left 2, up 8. And then here I'm going to go right or left 3 from the vertex. I'm going to go up 18. So it's going to put me all the way up at 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so we're at 3, up 10. Up 18, which puts me at 10. Left 3, up 18. And draw the curve in. Ah! There it goes. There it is. There. Whoop. There it is. All right, and that's it. So you're going to have 3 quadratics to graph as well on your assignment, and that's that. So hopefully it's not too much work. We got this week, next week, and the week after, and that's it. So hopefully all are doing well, and let me know if you have any questions through office hours, that sort of thing. Okay, thanks. Bye.